In this video, we are going to see a PLC example of a small production line where we do have let's go check the home so we get a bit enlarged. So we have parts coming out of this place which will be placed by operator or a robot, and then the parts will continuously go inside. There is this oven, and this oven is kept in a temperature which should be in between 320 and 350, and then after the parts go through this, there is a distance sensor. It measures, and if the distance is satisfactory, then it goes through. Otherwise, this sensor throws a signal, and after calculation, the PLC gives a signal to this pusher cylinder, and then that part which does not have the satisfactory height, this piston pushes it out of the conveyor. And here, just to make this video short, I wouldn't go much details into the setup. We are all set to go here. The connectivity is ready. I'm connected to the CAP server. The CAP server is running here with all the tags, and generated with absolute addressing here for Siemens PLC. We have the Siemens code running here in this virtual machine. Okay, I put it online, yeah, and I'm also connected to the virtual machine, in between virtual machine and the host machine, via a net to PLC sim. My PLC sim is also running here. This is running net to PLC sim. Okay, and the main function block to observe in this case is this one, which is an instance block of this function. The main data block, which is an instance of this function block 100 continuous run open. Okay, how this works: when a trigger, a starter trigger is given from the HMI, the line should start. Okay, so let's go. We put this on, and it's not running. As we can see that the conveyor, the motor is not on. So let's trigger it from the PLC. Let's have a look how this simulation components are working, and how the behaviors of these simulation components are connected to the PLC code. So I'm connected to the CAP server, and I would press run. In this case, my conveyor is not running, which should basically come from the PLC. I'm connected, all the signals are green, green, green. This means I'm good to go, and our CAP server is running here. Okay, so how this works: when the operator presses start trigger from the HMI, I didn't develop the HMI here until now. So when we trigger this one, it should trigger the general start on, and the conveyor should start running, feeding the parts. So we're gonna trigger this one, yes, and then I turn it off again. Let's go to simulation software. As you can see, the parts are generated, and they are going through the oven. And yeah, they're going through the oven, and if the distance, so this part was not satisfactory, it threw a signal, and it was the pusher cylinder pushed it out of the line. It's working this way. And how this code, we can see here. This is the main function of this program, and you can have a look. To make it more clear, I put it in a Visual Studio Code. So there are some key sections of here. The first, this one, it's scaling the temperature value from simulation software, is scaling the distance value from the simulation software. This is the part which takes care of the start function, and then if height is detected less than 103, then it throws this section, throws a signal to the push cylinder. And if general stop is detected from the HMI, if we want to close the line, then this part actually takes care of it. By the reason of general stop, or due to overload from the motor, if the conveyor line stops, then the operator must need to press reset before he can start the line again, and this part is doing their job. Alright, this code will be attached in the link, the description, so you can also have a look later. Alright, So I'll come back to here again, the PLC code, and we have some key functions here. One is this motor equip function, which is turning on and off the motor. This is the distance sensor scaling function, which scales the incoming value of 4 to 20 milliampere or 0 to 10 volt and scales it to the proper distance value which we need. And this also does the same but for temperature. Okay, we have this key data block here, and we can see that our motor output one coil is running. It's true. Okay, and then if I expand all of them, it's a bit heavy anyway, so we can see that we have these values here. The signal value is coming from simulation. The max value is also, you can change it from the simulation. So distance sensor signal and max values. Have a look how this looks like in the simulation software. So our distance sensor is here. I've already selected. I will go to home, and then the sonar sensor is one kind of distance sensor. So as you can see, it's measuring the distance. This one is getting to the PLC. I have selected a signal type from 0 to 10 volt. You can also check this one, and then you need to do some changes in the PLC code. Okay, so the higher limit we have defined 350. In this example, I have assumed that the lower limits are all for 0 to keep things simple. If the lower limit is not 0, is something else. So what we need to do, we need to go to the model tab of this component. Here, go to Python script, PLC sonar sensor, and you need to modify a little bit in this the code here. Then you can also use the different lower limit value. Okay, and so in this case, the other as you can see, if the conformity is not met, the pushes the parts out of the line. The second option is that the second option condition is that if this oven heat goes below, so I would like to select this one, and yeah, you can see the temperature. It's analog signal is throwing the analog signal, goes below this is in between 4 to 20 milliampere as per the code. If this temperature goes below let's have a look, 320, then it triggers the general stop through. That means it stops the conveyor. The parts shouldn't move. But in this case, I haven't stopped it yet now, because I have put this the weighted average value of below 320 values to 0 and 0. So what we need to do here is stop this one, and maybe I can put this 40, 60, 80, 90, 100. So it should the sum should be 100. All right. So let's reset, and then I would minimize this one, and we go to the connectivity tab to see what's happening. So it gives some values here to see if it is really running or not. We run this again. Okay, so it's on. And if this value goes below 320, this should turn off. Let's see what happens now. We are getting some values here. So temperature, analog signal. Maybe we can run it a bit faster. Oven temperature 329 degrees centigrade. You can see it here. So the probability of this temperature to go below 320 is around 20%. It should come fast. Let's see, 327 again, 327 again. Yeah. So you can see we got the oven temperature 295, and as soon as it went below this set limit 325, it stopped. So now the only way to start this line is that operator should go to the machine, and fix the issue so that the temperature can go up again. let's assume that operator has fixed the issue, and now we can see the temperature is back over 320. Yeah, so our simulation is running. In this case, it's again changed to 331. Okay, so he needs to do it this way, that let's go here and reset trigger, HMI, yes, and then yes, and then general stop, yeah, and then start trigger from HMI again, and then general start is on again. So it's turning and then the oven is running again until it gets a value which is less than 320, or an overload signal happens. So let's see what if we get overload. Okay, it stopped again. We got a signal which is actually basically, we can see here 395 degree. Okay, so the video is getting long, so to keep short, I will just show you another thing. If we press this one while this is running, motor overload signal from the simulation, the same way the conveyor should stop working. And have a look into the code inside the simulation components and in the PLC code, and we also I have done a smaller presentation explaining this stuff here for you. Hope things will get more clear for you. Yep. Okay, so thanks a lot for